We've got a mass hanging across this pulley here. This is a disc, and that string connects to the other mass. This is a frictionless surface, so when we let go of this mass, it falls down, it pulls this along with it, and because it's frictionless, it's like having little wheels on it. There's nothing to apply friction to it and slow its acceleration down. Alright, the blocks are released from rest. What's the acceleration of block M1? When this starts falling, this starts going this way, and this one starts falling at the same speed as this one starts moving. So they move at the same speed, they accelerate at the same speed as well. So if we can find the acceleration of this one, it's the same as this one, or the acceleration of both of them, it's all just the same. So I'm going to start by drawing the forces on this diagram. So we know there's a downwards force here, 0.1 kgs. This is the gravity force, is equal to 1 Newton. So there's a 1 Newton force downwards. There's an upwards force from the rope of tension, and that's equal and opposite to the tension pulling this guy. So I put a little lines to show that they're the same size. There's a 4 newtons gravity force down, but because it's on the surface here, there's a 4 newtons gravity force, normal force upwards, and they are equal. How I like drawing this, so it makes a lot more sense, is from the pulley here. I like unfolding pulleys, so I'm going to show you what I mean. Draw it over here. So this is the block M2, same place, and it's got this string, and here's the pulley here, and instead of the line going around here, and we've got this guy like this, I move this whole thing up the top here, unfold it, so it keeps going straight, and this is up the top. And because I move it up the top, these arrows have to be pulled around as well. So this one, as it gets pulled around, is now facing downwards. That's tension. This one's going that way, and the bottom one is now going this way. So it's 4 newtons tension. On the bottom, doesn't change. We've still got tension and 1 Newton. Tension is the same size as tension, 4. Now look at this as an entire system. Instead of just looking at one block at a time and the other block at a time, look at it as one big rigid structure that moves together. 4 newtons cancels out with 4 newtons, the tension cancels out with the tension. The only force on the whole system, the total force you've got left over, is 1 Newton. And that's what accelerates the system. So to work out the acceleration, we've got total force equals ma. So A equals total force over m equals this 1 Newton, the total force, which is this guy here. And the mass we use, because we're looking at this as one big system, is both the masses together, 0.4 and 0.1. So that equals 0.5. And 1 divided by 0.5 is 2 meters per second squared. Alright, what's the kinetic energy of the block M1, this block here, after it's travelled 1 meter? Okay, well, kinetic energy is equal to a half mv squared. We've got the mass. The mass is what are we looking at? M1. M1 is 0.4. And what's the velocity? We don't know the velocity after 1 meter, so we have to work that out. So we'll do it up here. The velocity equals question mark, we don't know. We know the initial speed equals 0. We know the distance we're looking at is 1 meter. And we know the acceleration, it's not 10, it's 2, what we've just worked out there. So what equation of motion has all of those in there? And the one that works is v squared equals u squared plus 2ax. So put everything in now, we get 0 squared plus 2 times 1. So v squared equals 4, so v equals 2. ms negative 1. So now we can put the velocity in here. So 2 and squared, don't forget the squared from the half mv squared. So we get a half times 0.4 times 4, which is equal to 0.8.